talk about properties of logarithms. Goal number 1 is to apply the product, quotient, and power rules. Goal number 2, we want to apply what's called the change of base formula. Goal number 3, to graph what's called the natural exponential and natural logarithmic functions. Okay, let's do a little verbal test. You guys were shown something like this. That's called exponential form. Can you convert that to logarithmic form? Yes.
Y equals log A.
Yeah, this is true if and only if, or I don't remember. In the video, I might have used the double-sided arrow. They both mean equivalent to. So a to the y equals x is equivalent to y equals log base a of x. That's essentially our working definition of logarithm or logarithmic form. This is log form, logarithmic form. This is exponential form. Okay, with that in mind, I introduce the 3 most important rules in this section, or in really having to do with logarithms. The first one is the product rule. For all of these rules, m and n and a are all bigger than 0, and a doesn't equal 1. So the product rule says this. It says that the log base a of m times n is equal to, this looks crazy, log base a of m plus log base a of n. The first time you see this, this looks kind of weird. So in other words, on the left side, the input is the product, m times n. The input to the log function is the product. Log base a of m times n, we're saying that's equal to log base a of just m plus the log base a of just n. Again, the parentheses around the inputs for a log function, they're optional. But it's the log base a, that's the name of the function. So if you call log base a f, then this is saying f of m times n. This is saying f of m times n is equal to f of m plus f of n. Only if f of x is equal to log base a of x. It doesn't normally work that way. You've never seen an example where it works this way. So it should seem weird to you. It works because of one of the laws of exponents and the fact that the logarithm is an exponent. Okay, so I want to express as a sum of logarithms log of 40, which is log of 5 times 8. So what does the product rule tell us? By the way, when you don't see the base, it's base 10. So what does the product rule tell us about the log base 10 of 5 times 8? You can split it up. Basically says, hey, that's equal to the log base 10 of 5 plus the log base 10 of 8. Again, you don't need to show these parentheses, and you don't need to show the base 10. Now, let's just make sure we believe it by plugging in both sides in our calculator. So if you type in log, okay, the log button is, a little further than midway down in the left-hand column of buttons. Log, that means log base 10. You can just type in 40, because 5 times 8 is 40. Hit enter, you get decimal, 1.60, blah, blah, blah. If the product rule is true, you should be able to take the log of 5 plus the log of 8 and get the same thing. So let's do that. Go log 5. Now you got to close, and the calculator, you do have to close those parentheses. The parentheses are there. So log of 5 plus log of 8. Same thing. Product rule holds at least for those numbers, right? And in fact, it'll always hold, as long as you plug in values that are non-zero into the logarithm. before we do the quotient rule, let's go the other way. What would log base 4 of u plus log base 4 of v equal according to the product rule? Let me remind you what the product rule says. The product rule says that log base a of m times n, it's like your input is m times n on the left side, is equal to the log base a of just the input of m plus the log base a of just the input of n. So which direction do we want to read this rule if we want to write this guy as a single logarithm? Right to left. So if you think of the base, what's the base there? Base 4 and then m, what's acting like m? U, and what's acting like n? V. Okay, so apply the rule to log base 4 of u plus log base 4 of v to make a single logarithm. What do you get? You get log base 4, and you just take the product of the two inputs, u times v. That's it. So what is it not equal to? I can imagine one mistake students might think. I'll do the mistake in purple. Okay, this is not the same as the log base 4 of u times the log base 4 of v, is it? But that would be an easy mistake to make. So try to avoid that one. Okay, that's the product rule. In this class, that's all you need to know. In your next class, if you take college algebra, you're going to go a lot more in depth and do a lot more with it. But in this class, we're just kind of introducing you to it.